All right, seventh graders, this is to continue on with the 1 and 2 step equation review. So it says, if 3/5 n plus 3 equals 18, what is the value of n? So we're just trying to solve for n. So we have 3/5 n plus 3 equals 18. Our first step is to undo any addition or subtraction to move all constants to one side of the equal sign. So right here, I'm trying to solve for n. So I first have to undo this addition or subtraction to move the 3 to the right side. So what's the opposite of addition? The opposite of addition is subtraction. So I'll subtract 3 from the left side of that equal sign, which means I need to subtract 3 from the right-hand side of that equal sign. 3 minus 3, those zero out. You don't need to write that 0 in. What am I left with now on the left side? On the left side, I'm now left with 3/5 n equals, what's 18 minus 3? 18 minus 3 is 15. Now you're just back to a one-step equation. The reason you spent so much time on one-step equations is because by the end, the last step in any multi-step equation falls back to solving a one-step. So then you look here and you say, what's the operation between the 3/5 and the n? Well, the operation between the 3/5 and the n is multiplication. How do we undo multiplication? We undo multiplication with division. At the 7th grade level, we show that division with the fraction bar. So what do I have to divide the side with the n, the side of the equal sign with the n by to get n by itself? To get n with a coefficient of 1, if n is being multiplied by 3/5, I must divide by 3/5 to get n all by itself. If I'm going to divide the left-hand side of an equal sign by 3/5, I must divide, using my fraction bar because I'm a 7th grader, the right-hand side of that equal sign by 3/5. What's 3/5 divided by 3/5? Oh, good, that's a fancy form of 1. 1n is just n equals, let's do a little scrap work. This is 15 divided by 3/5. So here's my little scrap work off to the side. 15 divided by 3/5. 15 is the same as 15 over 1. As 6th graders, you did your keep, change, flip. So I'm just going to use the standard algorithm. So I'm going to keep my first fraction, 15 over 1. I'm going to change my division to multiplication. I'm going to flip over this second fraction and make it 5 over 3. I can then multiply straight across the top, straight across the bottom. Could simplify first, but you could always just multiply straight across the top, straight across the bottom. 15 times 5 is 75. Over 1 times 3 is 3. 75 divided by 3 is 25. So n must be equal to 25. And I always show a check. So I'm just going to box in my scrap work. You're allowed to use calculators, so you could take 15, punch in divided by, and punch in 3/5 equals, you'll get your 25. I always show a check. So I have 3/5 times n plus 3 equals 18. In every check, you write your original equation back down. Then in place of n, I put a 25. So that's 3/5. And now when I put my 25 in place of n, I have to show the operation between the 3/5 and the 25. Well, the operation between, if you don't see an operation, you assume it's multiplication. So it's 3/5 times 25 plus 3 equals 18. So here I'm going to choose to put 25 as 25 over 1. I'm going to simplify this first. 5 goes into 5 once. 5 goes into 25 5 times. Straight across the top, straight across the bottom. 3 times 5 is 15. 1 times 1 is 1. 15 over 1 is just 15. And then I still have this plus 3. And I'm hoping that's 18. I usually put little question marks because I'm like, oh, I hope it's 18. And then 15 plus 3 is 18. 18 equals 18. The whole purpose for the check, and if you really actually substitute the numbers in, actually simplify this side of the equation, actually get what's on the other side, you're guaranteed this number up here is correct. That's why we do checks. All right, moving on. All right, a rectangle is constructed with 12 feet of string. Suppose the length is 3 1/3 feet long. What is the width? All right, so I'm going to construct a rectangle. I'm given that the length is 3 1/3 feet, so this is 3 1/3 feet. That side of the rectangle is 3 1/3, the top side is 3 1/3. And it's constructed with 12 feet of string. If it's constructed with 12 feet of string, it means you use the string to construct the outer edge. That will be perimeter. If we're talking about the outer edge, that's perimeter. And the perimeter is 12 feet. All right. So how do we find perimeter? Oh, we add up all the sides. To find perimeter, add up all sides of the rectangle. I'm going to write an equation for this because that's the unit you're in, but there's several ways to go about this. I'm just going to call the width W. So I'm going to let W equal the width. Let statements are important. We have to know what that W is. They were looking for the width, so that's what I name my variable, whatever they're looking for. So if I was going to add this up, I would have to do W plus 3 1/3 plus 3 1/3, adding up all the sides, equals my perimeter of 12. So this is add up sides. Set that equal to your perimeter, whatever they tell you your perimeter is. So what's W plus W? Well, that's really 1W plus 1W. 1W plus 1W is 2W plus, what's 3 1/3 plus 3 1/3? Well, 3 plus 3 is 6. 1/3 plus 1/3 is 2/3. Equals 12. Now I'm going to go ahead and solve this equation. First step in solving a two-step equation, undo any addition or subtraction. So I'm going to undo this addition with subtraction. So I'm going to subtract 6 2/3. So on this side I'm going to subtract 6 2/3. 6 2/3 minus 6 2/3, those zero out. So on the left side I'm just left with 2W equals 12 minus 6 2/3. Well, you have a calculator, go ahead and use it. I need to borrow. I need to get a certain amount of thirds here. Well, if I borrow from the 12 becomes an 11. How many thirds did I just borrow? I borrowed one whole. In one whole circle, there is 1, 2, 3 thirds. So if you borrow one whole, you've borrowed 3 thirds. So now I just go ahead and subtract this. 3 thirds minus 2 thirds is 1/3. 11 minus 6 is 5. And it makes sense. If you have 12 minus 6, you're at 6. Subtract away another 2/3, you're at 5 1/3. All right. Now I look here in my very last step. Again, I'm down to a one-step equation. What's the operation between the 2 and the W? The operation between the 2 and the W is multiplication. How do I undo multiplication? I undo multiplication with division. So I'm going to use my fraction bar for division. On the left-hand side of the equal sign, I'll divide by a 2, which means when I go to the right-hand side of the equal sign, I need to divide by 2. 2 divided by 2, fancy form of 1, bye-bye. This side I'm left with W equals, now I got to do a little scrap off to the side. This was 1 equals 3 thirds. That's what that little picture means. So here's my scrap off to the side. I have 5 1/3 divided by 2. So I have to write this as an improper. 3 times 5 is 15, and one more is, I must have 16 thirds divided by 2. 2 is the same as 2 over 1. Keep, change, flip. Keep your 16 thirds. Change your division to multiplication, flip over that second fraction. Some of you like to find common denominators and then divide straight across the top, straight across the bottom. That's always another option. I'm going to go ahead and simplify first. 2 goes into 2 once, 2 goes into 16 8 times. Straight across the top, straight across the bottom would be 8/3. So the width is 8/3. But none of these say 8/3. Oh, they must want me to rewrite it as a mixed number. 3 goes into 8 twice. How many left over? 3 times 2 is 6. 6 plus 2 gets me to 8. So it must be 2 2/3. Again, I could draw a visual. If I have 8/3, if I have 8/3, 2 whole gets me to 1, 2, 3, 4, 5, 6/3. And then I have 2/3 of another circle. So 8/3. 1, 2, 3, 4, 5, 6, 7, 8/3 is the same as 2 whole circles and 2/3 of another circle. So that's my answer. And I could always do a check. For my check, it's now that I know my widths are 2 2/3, I'm just going to add up all my sides. 3 1/3, 3 1/3. For my lengths, 2 2/3, 2 2/3. Just going to go ahead and add those up. All of my fractions are already in thirds. 1 plus 1 is 2, plus 2 is 4, plus 2, so that's 6/3. And then here, 3, 6, 7, 8, 9, 10. 10 6/3. Well, 6/3 is 2 whole circles, so 10 and 2 more whole circles, we're up to 12 feet. I find with word problems, the checks are a little bit easier for me. All right, let's keep moving on. See if I can do one more problem. Oh yeah, it's a solving. We should be able to do this. So 8 equals, they want us to solve for n over 3 plus 5. When we're solving a two-step equation, first step is to undo any addition or subtraction to get all constants moved to one side of the equal sign. The opposite of adding 5 would be subtracting 5 off from the right-hand side of this equal sign. If I'm going to subtract 5 from the right-hand side, I need to subtract 5 from the left-hand side. 5 minus 5, those zero out. On the right-hand side, what am I left with? N over 3 equals 8 minus 5 is 3. Down to a one-step equation to solve for n. What's the operation between the n and the 3? The operation between is division. How do I undo division? I undo division with multiplication, which means I need to multiply the right-hand side of this equal sign by 3, which says I'm going to multiply the left-hand side by 3. Whatever you do to one side, you do to the other. 3 over 3, fancy form of 1. So I'm left with n on this side. 3 times 3 is 9. Oh, on your test or quiz, I'm sure your teacher will ask you to show a check. All right, so if we needed to show a check, first step in any check is to write down the original. 8 equals n over 3 plus 5. Place of n, I have to substitute 9. 9 over 3 plus 5. What's the operation between the 9 and the 3? Well, that's division. I'm going to simplify this side. That's division. 9 divided by 3 is 3. So I'm just working down this side. 9 divided by 3 is 3. Ooh, I hope those sides will end up equal. Oh, 3 plus 5 is 8. Sure enough, those are equal. It says I got to the correct answer here. N really is 9 because when I actually substituted n into the equation and simplified, I got the two sides to check. I hope that helps. I'll do one more video for the last couple of problems. Oops.